Welcome to today's webinar, which is Large Assembly Modelling Update for SOLIDWORKS 2018 and 2019. My name's Craig Stevens. I'm an application engineer and also a field engineer for Central Innovation. I've got about 25 years of experience with CAD and over 20 years experience with SOLIDWORKS, and I've been certified as a SOLIDWORKS expert and also as a data management for SOLIDWORKS PDM. So that's just a little bit about my background. Moving on to today's agenda. For SOLIDWORKS 2018, we'll have a look at the Assembly Progress Indicator tool, which was new for 2018, and then we'll move on to talk about the enhancements in the Performance Evaluation tool. We'll talk about some options that are related from there. We'll move on to the Assembly Visualization tool enhancements, and then look at some improvements for speedpak in 2018. And then for SOLIDWORKS 2019, there have been some good improvements for large design review. We'll have a look at how we can better manage the mates folder with some grouping options, and we'll round it off with performance evaluation tool improvements for SOLIDWORKS 2019. So let's start off with the 2018 version. So whenever you open an assembly now in SOLIDWORKS in 2018 and also 2019, you'll see the Assembly Progress Indicator. And this provides some information to us on the various operations that are going on in the background when we actually open an assembly. So what's actually happening in the background is not new. It's just that we get to see SOLIDWORKS moving through those various stages. It tells us how many components are being opened for the top level assembly, and also any documents that have been referenced. It then moves on to the update assembly features, which updates the models, the mates, assembly features, patterns, and in-context models. And then the last stage there that it goes through is updating the graphics area. It also tells us how long it's taken to open with the elapsed time there. Yeah. It gives us a previous time to open. It shows the amount of time required to open the assembly the last time it was opened. Just be aware that that previous time to open operations is specific to the assembly mode. So it's saved for large assembly mode, lightweight mode, and resolve mode. So depending on which mode you're opening in, it might vary from what the last open time was. Let's take a look with an assembly in SOLIDWORKS. So I'm just going to switch to SOLIDWORKS 2018. And then I'm just going to go into the File menu and open up my cabinet assembly. And you'll see the dialog open up there. Not quite sure how well this will translate over the webinar, but you'll see the end result once it's completed there. Okay, it's asking for a rebuild, so we'll just execute that. It's going into the update assembly mode, so it's now updating the assembly. And once it's done that, it moves to the generating graphics. And once it's done that, then it can go ahead and open up the model. And that dialog doesn't stay on the screen for too long. So once the model's been opened, if we want to see that information again, then we can go to the Performance Evaluation tool. All right, so let's talk about some of the changes to the Performance Evaluation tool, and we'll just switch back to the PowerPoint for that. In the 2018 version of the Performance Evaluation tool, they've basically categorized all of the various information that's contained within that and broken it down into 5 separate areas: open performance, display performance, rebuild performance, settings performance, and statistics. In SOLIDWORKS 2016, SOLIDWORKS began the process of making improvements to the reporting tool of assembly detail through the performance evaluation tool. Previously, this tool was called the Assembly Expert, so in 2014, 2015, it was called Assembly Expert, and provided pretty limited information in terms of troubleshooting assembly performance issues. And it largely only provided the statistics, which is sort of the bottom category that we see there in the evaluation tool now. 2018's received probably the largest update since the change, and we'll take a look at each of these areas that are now available and listed on the screen. So first, let's take a look at the open performance section. So what this does is it lists the files by the amount of time required to open the file under the details of the open document file section or subsection there. If the files are from an older release, it indicates the number of files that are updated while the assembly opens. Let's take a look at that in SOLIDWORKS. Just wait till everyone can see the screen there. Looks like everyone can, so I'm just going to click on the Performance Evaluation tool. That's available on the Evaluate tab of the Command Manager. It's the easiest place to get to it. You can also access it from the Tools menu. So looking at the dialog here, we've got the details of the open document file, and it lists the file names of the documents that have been opened, the configuration that's been opened, the open time, and it gives us a bar on the right hand side that's sort of coloured in green there, which correlates to the opening time. And if we scroll down through that list, you'll see that it's listed from largest opening time to the smallest. Just be aware that there are two separate columns there, one for the open time and also one for the bars. And you'll see a difference there when we have a look at the changes that have occurred to this in 2019. So just keep that in mind. A bit further down, we've got the reference here to previous version references. We can actually click to show the files that have been converted. So if I have a look at that, it says these have been updated to the latest version. This only happens during the live session. So if you don't click save, they're not actually saved in that latest version. They're just opened or converted to the current version so that they can be worked with. And that can be a real performance problem if they're not actually in the current version that you're working in. I'll just close that off for now. Just coming back to the PowerPoint presentation again. For the performance evaluation under open performance, modified on opened was supposed to be shown in the 2018 version, which does pretty much exactly what we just saw. It was listed as previous version references, but it's been updated to modified on open. That was fixed in the 2019 beta, so when we look in a 2019 release now, it'll actually show modified on open. And as I mentioned, that's always recommended that you upgrade your files when migrating to a new release to avoid those performance issues. Moving on to display performance. This dialog shows quite a bit of information. There are 5 main areas that can appear here. The top one there is graphics triangles. And this lists files by the number of triangles contained in the part. Files with less than 5,000 graphics triangles are generally not listed. What does 5,000 triangles look like? Well, if I just switch over to SOLIDWORKS and let's take a look at a very simple SOLIDWORKS file, just a cube. If I go into the File menu and go to Save As and change to the STL file format and look at my options, if I hit the preview before saving option in here, it'll actually tell me how many triangles are in that model. Now for a cube that's got 6 sides, when you triangulate that mesh, the minimum number of triangles you can have is 12, so that's 2 triangles per side. And if I click OK and hit the save button, you can actually see the triangulation in the background. So as I said, 2 triangles per side for a 6-sided cube. Okay, so that's a fairly simple example. If we take a look at something that's a little bit more complex, like a sphere, and keeping in mind that that cube was 100 by 100 mil in all directions, this sphere's got 100 mil diameter. If I go through the same process and do a save as, and look at that in an STL file format, and have a look at my options, you can actually see the preview in the background of that. Looking with a coarse resolution, which is the lowest possible resolution we can export, that's got around 2,300 triangles to approximate the shape and size of that sphere. If I change that to a fine or a custom, it bumps it up to about 6,000. So anything slightly more complex than a sphere is going to definitely appear in the graphics triangles list. So it doesn't take a great deal of detail to actually go beyond 5,000 triangles. Okay, so let's do some performance evaluation here and look at our display performance. So you can see quite a number of these models have in excess of 5,000 triangles. Okay, but anything under that count isn't shown. And if we wanted to see those files, we could click on the Show These Files option here. One of the other indicators that are shown here is shaded image quality, and there's actually this is broken down into 2 distinct categories. If we have a look at the first one, it says that one part has medium high range image quality set in the document properties. If I click on Show These Files, it'll tell me that our part, the cooker hood vent assembly, has that medium high range quality set. So, sorry, cooker hood vent assembly. We will take a look at that. Okay, so I'm just using the filter at the top of the design tree to actually search for that part file there. And I can right click on my cooker hood and open the subassembly. Okay, so just showing the dialogue there. And if I go into the system options for this particular assembly and go to the document properties and have a look at the image quality, you'll see that the image quality is sitting around about the mid-range. So usually anything sort of, I think it's about 60 to 80% will be flagged into that mid-high range. So we could come in here and drop that back to a lower setting for the large assembly. Coming back to our main assembly again, if we scroll down and take a look at the next setting under shaded image quality, it tells us that there are 212 parts that have very high image quality set in the document properties. So I'm just going to show those files, and I can see that the SpinFlow sync here, which is the assembly, has that. So we'll try and track that one down as well. So if I open up that sub-assembly there, and take a look at the system option of document properties and image quality, you'll see that this indeed does have very high image quality setting. And so in this particular case, we'd probably look to reduce that image quality. Image quality can have a significant performance impact on dealing with large assemblies, and it's probably one of the #1 things that causes performance degradation in large assemblies. Alright, so let's just cancel out of that. And then we'll go back to our main assembly there. And going back to the performance evaluation dialog, the last one we see there listed for the display performance is appearance. And it tells us here that 7 documents contain over 100 appearances applied to the face, and this can affect assembly performance. So I'm just going to check out which files they are. And one of those there is the pantry base, and that looks like it's got 751 appearances applied to it. So we'll just check out that that component there. Alright, so let's just open up that part. And if I take a look at the Display Manager tab and have a look at my appearances and change the sort order to hierarchical, and have a look at the face type, you can see that there are quite a large number of faces that have had individual appearances set, which in this case is not too bad, but I'd probably suggest that you need to, change that so that it was applied to faces or the whole body rather than individual, just in an individual face, and that'll sort out that issue. Switching back to our main assembly there, and just going back to performance evaluation. That's the last one that we see for this model here. Switch back, PowerPoint. There's a couple of other things that can appear there. One is display speed, and this indicates if the display speed is too slow during the dynamic view operations like zoom, pan, and rotate. And generally, if they appear as a problem, you've got the option to turn off things like shadows and real view. Okay. Sorry about that, guys. We'll press on. So just going back to the display speed, this indicates if the display speed is too slow during the dynamic view operations, as I mentioned. You can also minimize textures there as well, which will should improve the performance if zooming, panning, and rotating are slow. The other option there is components far from origin. This appears for assemblies that have a bounding box larger than 1,000 meters. If one or more components are far from the assembly origin, then the assembly seems to disappear when you zoom to fit. The assembly zooms far out to include the components near the origin as well as those far from the origin. Generally, when this happens in the performance evaluation tool, there'll be a fix-it button that appears in the display performance area. And what this will do, it will move the stray components closer to the origin. There have been improvements in previous releases which have resulted in this occurring less often, so we don't tend to see it as much as an issue now, since about SolidWorks 2017, I believe. Unfortunately, I don't have a sample to show you that, because normally if we have that issue, it's pretty easy to jump in and click the fix it button and fix that. So What we'll do is move on to the rebuild performance section of the performance evaluation tool. So I'm just going to click on the next slide there. So what we see here, at a minimum, if the model's not been rebuilt in the current version of SolidWorks, you'll see a message there about rebuild data is not available and some tests cannot be performed. That's not shown in my screen capture there, but it can come up if you're opening models that have got previous versions of SolidWorks model data in there. What we typically see though is the rebuild report. It reports the rebuild time for the total assembly. The report shows the time taken to rebuild significant components and features. Any minor items are omitted, so if they don't take a long time, they won't be shown. Complex relationships may cause some items to be visited twice, but again, not available when the assembly rebuild time is less than 10 milliseconds. In SolidWorks 2018, the in-context circular reference check is renamed to Assembly Rebuild Report. There's also the other option there for mates, and this checks the number of mates that are evaluated when the assembly rebuilds and the amount of time taken to evaluate those mates. That's also shown in the rebuild report there. Certain mating conditions can result in slower rebuild times. If the mates rebuild slowly, performance evaluation reports any mates that reference assembly features or pattern components. For assembly features, mates that reference assembly features rebuild slowly compared to mates that reference component geometry. It's generally recommended as a best practice not to mate to assembly features. For pattern components, mates that reference instances of the components that are generated by a component pattern rebuild slowly compared to mates that reference non-pattern components. So again, best practice, don't set up mates that reference instances of components that are generated by a pattern. The dialog will also report on specific conditions. So if we just go to the next slide, there are some conditions, and these conditions are not necessarily indicative of errors, but modifying those may improve your performance, but you need to weigh that up against your design intent. Okay, so moving on to the settings performance. There are two settings that are shown here. First one is verification on rebuild. When this option is off, the software checks every new or changed feature against any adjacent face and edge. For most situations, this default level of error checking is adequate. The result is faster rebuilding of the model. The screen capture there shows that the verification is on rebuild is enabled. This option checks every new or changed feature against all existing faces and edges, and that can slow the rebuild down. So the difference there is what it's actually checking against. So when it's enabled, it checks against every new or changed feature. When it's not enabled, it just checks against, it only checks against the features which are adjacent to it. And I guess the difference in terms of performance, the rebuild can be 30 to 35% slower when that's actually active. The other option there is a large assembly mode. This reports on the resolved components, the large assembly threshold, and whether or not large assembly mode is switched on. And in the screen capture there, it's currently switched to off. If we just quickly look at SolidWorks, and I just want to explain about the verification on rebuild. There are two options. So generally speaking, it's turned on in the performance page. It's right at the top of that page. I'll just wait till the audience view updates there. Everyone can see it. So right at the top of this page, verification on rebuild, enabled advanced body checking is activated. If we go into the assemblies page, there is an option in here that we can disable verification on rebuild for the assembly level. So what that does is it still allows verification on rebuild at the part level if it's set in the system options to check the parts, but for assemblies it will actually disable that verification and thereby improve the performance when you're dealing with the assembly level. Okay. So we'll move on to the next slide. Which is the final section of the performance evaluation tool, and this is the statistics area. There isn't a lot that's changed here other than some of the descriptions. What you see here is basically some stats on parts, subassemblies, components, and the assembly itself. What is new here is the assembly visualization button on the toolbar at the bottom of that dialog. And that takes us directly to the assembly visualization tool from the performance evaluation dialog. So let's talk about large assembly modeling in terms of the assembly visualization tool for 2018. They've updated the user interface, so the buttons are on the same line as the filter now, and they've also added a button there, which is the performance analysis button. In the screen captures I've got on the page there, in the top it's not activated, in the bottom it is activated. When it is activated, it automatically removes the mass column and adds the total graphics triangles, SolidWorks open time and SolidWorks rebuild time columns for the visualization tool in SolidWorks. That's probably a good time saver because they're probably the three most commonly used columns when analyzing an assembly from this tool. Mass is probably not used as much, so having that button there is a huge time saver in 2018. All right, the next highlight I want to discuss for the 2018 release is the speedpak configuration. So let's take a look at that. And what they've done here is look at ways of improving the updating in speedpak. So this has probably been one of the main sticking points on people using it, is that it hasn't previously been able to update automatically. Now we can set a rebuild mark on the configuration so that when we do a save, it automatically updates those configurations. And we've also got the option to update speedpak configurations automatically. So it used to be that we would have to go in and update those manually. Now we can do it automatically. What that looks like in SolidWorks, let's just close this file off. And we'll open up an assembly that's got some speedpak configurations in it. waiting for that to update for the audience. Looks like most people can see that now. So if I switch to the configuration manager, and expand the configurations here, you can see that there are 2 speedpak configurations listed. If I right click on the configuration and go to edit speedpak, then it brings up the details for that speedpak. If I move towards the bottom of that speedpak, you'll see in the options there that it's got add rebuild on save mark. So what that means is when I save this file, it will rebuild that speedpak configuration. The other option that I showed you, if we go into system options and go to assemblies, there's an option about a third of the way down the page, update out of date speedpak configurations when saving files, and there's a drop down there which allows us to access whether we want to update all of the configurations, none of them, or only the ones that have got the rebuild on save mark. And keeping in mind that these are system-wide options that will affect any assemblies that have got that information set. Okay. So let's move on now to the 2019 updates. In SOLIDWORKS 2019, you can use edit assembly option to edit assemblies in large design review mode. There's a checkbox that has to be selected from the open dialog. The editing is limited. It allows you to insert components and to make those components. And we'll talk about some of the supported types and geometry which are available, and also whether they're temporarily fixed or not. The other option that we've got access to is moving components with the triad via a right mouse click. So let's have a look at the model in SOLIDWORKS 2019. It's going to open up a model here. Actually, if you open it from the file menu, you don't actually get the option to do the editing. So this might take a minute to open up here. Just while we're waiting for that to open. Almost there. So you can see on the dialog there, it said it was last opened in 40 seconds. That's because it was opened in large design review, so it took a little bit longer to fully resolve that. I'm just going to close it, and I'm just going to go to the file menu and go to open, and this time I'm going to click on the assembly there, I'm going to switch the mode to large design review, and you'll see that there's a new option here, edit assembly. I'm going to click on the edit assembly box and open that up. It should open much more quickly. You'll notice that we don't get the dialogue at the start because we're going into large design review. You'll also note that that we are in large design review because all of the icons have an eye overlaid on them, so that's an indicator that you are in large design review. You'll also notice on the main toolbar that we've got some options there for insert components and mating. So if I just rotate this model around and zoom in, I'm just going to select on one of the sub-assemblies here. Just going to delete that sub-assembly. So we can actually do deletions in large design review. And I'm just going to pop a new component in there. I'm going to pick up the pump assembly and open that up. You'll notice we've got the options here to rotate the components, so we can still do that when we're dropping that in. And I can just drop that in to the assembly. And then I've got some mate options, so if I want to align that with the previous components that it was aligned to, I've got my standard mates available, so I'm just going to pick the circular edge there, and I'll pick the outside face of this model here, so you can pick those types of geometry and make that a concentric mate. Click OK. Looks like that's gone a fair distance away from there, so we'll just grab that front face. And the matching face on this component here. And we'll make that coincident. Click OK. Exit out of the mate dialog and go back to our previous views. And you'll see that it's dropped that pump in. Magnetic mates also work in large design review, so if I go to insert one of these condensers, which has been pre-configured with a magnetic mate, when I bring that in, you'll see the magnetic mate references there. And just rotate that around so it's in the right orientation, and if I drop it onto the next node, when I drop that in, after a short wait there, you just click on the magnetic mate button. You'll see that it's positioned it alongside the other condenser using magnetic mates only, so it's fully aligned that into position, which is a real neat time saver if you set those up. For magnetic mates in large design review, you can edit the ground plane, so we do see the ground plane feature in the large design. So if I just scroll down, right down here, below the mates folder, we can see the ground plane definition, so it snaps onto that with the magnetic mates. You can create, edit and delete ground plane features, but you cannot edit the published references or define new connection points in the large design review, so they need to be set up in large assembly mode, most likely. All right, let's go back to the PowerPoint. So for large design review, the types of mates that are available are things like angle, coincident, concentric, distance, etc. The list's there on the page. And the types of references that we can use are things like arc edges, linear edges, planar faces, cylindrical faces, etc. For geometry, or for mates that aren't actually supported in large design review, the component reference the components referenced by this mate are temporarily fixed, and you'll see that in the model under the mates. Okay. Some of the limitations in large design review. If you want to use the edit function, you need to save the entire assembly and all of its components in the 2019 file format. You can do that using the Save All option. And you'll note on the PowerPoint there that I've got a screen capture. If you do click on it while it's running that Save As command, we've got a new dialog there that shows the resource usage, so CPU and memory. I happened to catch that while it was using no CPU, but it was varying between about 7 and 10%. Obviously, while it's doing that, you want to wait for the command to finish, which is the recommended option. So just a little bit more feedback on that, rather than just getting a not responding message. Unfortunately, if you've got assembly features or feature-driven patterns, they can't be used if you want to be able to edit the assembly in large design review mode. Reference geometry, sketches, and component patterns will be shown, but they'll be read only. The origin, standard planes, and mates folder can be referenced when you're in the edit assembly mode of large design review. And speaking of the mates folder, let's take a look at how to get that organized in SOLIDWORKS 2019. So we've got the ability now to group mates by status. So we can see them if they've been solved, if they're in an error or over-defined state. We can see them if they've been suppressed, or if the file is actually missing. Excuse me. We can also see if there are any inactive mates, in this case if they've been fixed. So switching back to SOLIDWORKS 2019, let's just close this file off for now. And we'll open up a file where we can group some mates. And as you can see here, there are a few errors in there. That's by design so that we can actually see what goes on in the mates folder. So if I expand that, currently it hasn't been grouped. All of the mates are all mixed in together, which is not very clear. So I just right click on the mate group, select the group mates option, and I'm going to go by status just to start off with. And you'll see that it's collected all of the solved mates. There's 100 of them into its own folder, so I can collapse that folder. And then I can see specific folders for mates that have errors, if they're over-defined, if they've been suppressed and are missing, or if they've been fixed and are inactive. Okay, so just going back to the PowerPoint. We can also group mates into a folder for fasteners, so into a separate fasteners folder inside the mates folder. It includes suppressed baits that are referencing toolbox components, and if it's sorted by status, it will be a subfolder of the status folder. So if I just flip back to SolidWorks 19, and if I now group the mates by separate fasteners as well, you'll see at the bottom of the list here we've got a fasteners folder where it's collected 60 fasteners. If I click on that and collapse it, it's removed those from the solved top level and placed them into a subfolder there. If they are in error, the fasteners folders would be a sub folder of the errors folder. Okay. So just rounding it off with the performance evaluation tool improvements for 2019. There's only a few of them because, as I said, most of the changes have been made in 2018. One of the key ones, though, is that the open file from report option is available. So when we look at that report there at the top of the screen, there are now some open folders shown alongside, and we can click on those to actually open the file directly from inside the performance evaluation tool. You'll actually need to close the performance evaluation tool, though, once you've opened it from there to be able to access it. You'll also notice that the value bars are now shown in the same column as the open time, and the open time is actually overlaid over those bars, so it kind of makes that that dialogue a little bit more tidy. The other thing is that the assembly rebuild report has been updated. This used to just be a field which had everything grayed out. You can now expand and collapse those nodes in the operations section, and any problematic areas are shown highlighted in red there. So that makes that a bit easier to navigate when you've got some issues in there. Components that are rebuilt more than one time appear in red. Components that take 10 milliseconds or less to rebuild are omitted from the list, and that's also the same as what was mentioned for the 2018 version. And that pretty much brings us to the end of the webinar. So if there are any questions, thank you for attending our webinar, and also for being a Central Innovation customer. Again, if you've got any questions, please feel free to email me.